Welcome back, Focus Learners. So today, we're looking at the literal ground beneath our feet. I mean, we all know it's the foundation of our ecosystems, right? But looking closer, this explainer is going to show you that soil isn't just mere dirt. It's actually a living, breathing architecture beneath every forest, farm, and footstep that is way more complex than it usually gets credit for. Okay, let's dive into this, because the sheer scale of what we're dealing with here is, well, it's truly staggering. Did you know that a single teaspoon of healthy soil can hold billions of microorganisms? Literally billions. That means in just one handful of Earth, you've got more living things than there are human beings on the entire planet. So right out of the gate, we have to shatter this preconception that we're just looking at inanimate dust. We are actually looking at one of the most complex, biologically active habitats on Earth.
Section 1. More than just dirt. A delicate recipe for life.
So the crucial point is the delicate balance of this composition. You might just assume soil is entirely solid matter, right? Actually, scratch that. Half of an ideal soil volume is actually completely empty space. It's like a giant sponge. That empty space is divided evenly into 25% water, which, delivers nutrients to the roots, and 25% air, which provides essential oxygen and carbon dioxide for both the roots and all those soil organisms we just talked about. The solid half, that's made of 45% minerals, your sand, silt, and clay particles. And finally, we have that small but mighty 5% slice of organic matter, which is packed with humus from decayed plants and animals. It's an incredibly precise recipe.
Section 2. The birth of soil. A centuries-long journey. Creating soil is a really slow, deliberate process. We're talking hundreds, sometimes even thousands of years here. It all kicks off with step 1, weathering. This is where the sheer force of wind, water, ice, and intense heat physically breaks solid rock down into smaller fragments. Over time, we move to step 2, where this fragmented rock accumulates into what we call the parent material, basically the foundational mineral base of our future soil. Then, life enters the equation. Step 3 is organic input. Plants, microbes, animals, they all move in, live their lives, and eventually decay, adding that absolutely crucial organic matter into the mix. Finally, in step 4, horizon formation happens. As all those minerals and nutrients settle over vast stretches of time, you get these beautifully distinct layers developing in the Earth. Section 3. Layers, types, and properties. The anatomy of the Earth. Let's move to and see how this builds our structural layers.
If you were to go out and dig a really deep trench, you'd uncover these distinct layers, which scientists call soil horizons. Starting right at the surface, you've got the O layer, the organic layer. This is pretty much entirely leaf litter and decomposing stuff. Dig just below that and you hit the A layer, or topsoil. This one is super rich in humus and minerals, and it's actually where the vast majority of plant roots grow. Moving further down, we hit the B layer, the subsoil. Here, clay and minerals that have leached down from above really start to accumulate. Next is the C layer, that parent material we mentioned a minute ago, which is mostly just weathered rock fragments. Very little organic content down there. And finally, at the very bottom, you hit the R layer, the solid, unweathered bedrock that lies beneath the whole shebang.
Now, beyond just its layers, soil is also classified by its particle size, and this creates a massive trade-off when it comes to drainage and nutrients. Let's look at the extremes. On one side, we have sandy soil. Sand has really large particles, it feels super gritty, and water drains through it very fast. But because the water flushes right through, it has terrible nutrient retention. Now, on the exact opposite end of the spectrum, we've got clay soil. Clay is made up of tiny microscopic particles, it feels super sticky to the touch, and it holds on to nutrients incredibly well. The catch? It suffers from very, very poor drainage. Fortunately, there's a middle ground here. Silty soil sits right between sand and clay. It's smooth, fertile, and holds on to moisture a lot better than sand does. But the absolute holy grail for agriculture is loamy soil. Loam is this perfectly balanced mix of sand, silt, and clay. Because it draws on the absolute best characteristics of all three, it creates the ideal environment for most plant growth. It's really the gold standard for sure. So when scientists are out testing soil health, they're looking closely at a couple of critical properties. First up, measuring the pH level is absolutely crucial to track acidity or alkalinity. Most crops strongly prefer a nice neutral sweet spot right between 6.0 and 7.0. Next, we have to measure drainage speed. Water needs to move through that soil structure efficiently. Because think about it, if it drains too slowly, the lack of oxygen will literally drown the plant roots. They need to breathe too.
Section 4. The engine of life. Global impact.
Okay, let's zoom out a bit. Here is the reality of our reliance on this system. And it is a monumental fact. 95% of our food is grown directly or indirectly in soil. 95%. Soil anchors the plant roots and supplies the necessary nutrients that grow nearly all of our crops worldwide. So whether you're crunching on an apple or drinking milk from a cow that grazed on pasture, without this living foundation, our entire global crop production and food system would simply collapse.
Now, what's really interesting about this slide is that soil actually has this massive hidden role beyond just growing our food. On one hand, it acts as an unbelievable biodiversity hub, housing a full 25% of all species on Earth. We're talking earthworms, insects, and these vast, sprawling networks of fungi. And on the other hand, it plays an essential role in climate stability. Soil is actually a global vault for carbon storage. Amazingly, the soils of the world hold more carbon than the atmosphere and all the plants on Earth combined. No way, right? But it's true. It is an absolutely critical stabilizer for our planet's environment.
Section 5. Protecting our foundation. Threats versus solutions.
As much as it does for us, this critical public utility is facing unprecedented human-made threats today. We're talking severe erosion, rampant deforestation, chemical overuse, sealing over everything with urban concrete, and deep, deep nutrient depletion. But the good news? For every one of these threats, we actually have actionable, proven conservation practices. We can counter erosion with cover cropping and no-till farming methods so we don't expose bare earth. We can combat deforestation with targeted reforestation efforts. And instead of depleting all the nutrients with chemicals, we can utilize crop rotation and composting to naturally rebuild that organic matter and save our foundation. So, to pull it all together, soil is clearly not some quick-fix resource. It's a wildly complex, life-sustaining system that forms over centuries from weathered rock and organic matter. We saw how it's deeply structured into those distinct O, A, B, C, and R horizons, and how it completely relies on that perfect 50-50 balance of empty space for air and water mixed with minerals and organic matter. But most importantly, it's the invisible engine that sustains our food, filters our water, houses our biodiversity, and stabilizes our climate.
Which leaves us with this final thought. We rely on soil for 95% of everything we eat. It is the literal bedrock of human civilization. And the solutions to conserve it? Well, they're entirely within our grasp. So will we protect the living foundation beneath our feet? Take a moment to ponder that relationship we have with the Earth. Thank you so much for joining this explainer. If you want to dig a little deeper with us, join us next time as we explore the fascinating world of soil pH and its direct impact on plant growth. Stay focused and keep learning.